Hello guys, welcome back. We are going to see today question that we have is 662 maximum width of binary tree. So we have to find the maximum width of a binary tree, right? And what we have to do actually, so from the maximum we have to find the maximum width among all the levels of the given tree, right? So maximum width we will find of a tree. So width of one level is defined as the length between two end nodes, you can say the leftmost and the rightmost, and not null, you can say non null means not null nodes, where the null nodes between n nodes that would be present in the complete binary tree, that would be, you can say, present in the complete binary tree extending down to the level counted in the length, right? And it is guaranteed that the answer will be in the range 32. So this is the we have this complete binary tree we have given, right? So if you'll find the length, right, what we will do, we can see after this is the complete binary tree. So the leftmost is this one and the rightmost is this one. So if you'll see the distance, right, 1 2 3, right, and this is 4 we have, right? So total 4 output we are getting, as you can see, right, as you understand, right? From the leftmost and between the leftmost and the rightmost, the, you can say, and nodes, we have to find the distance, right? Similarly, if you'll see this, if you convert into the binary, you can say complete binary tree, it will have the 7 h value, and if you make the you can say complete binary, if you consider the complete binary, you will get the length of this one, as you can see, the length between 3 and 2, okay, right? Leftmost and rightmost we have to make. After completing this, right, you should have little understanding of binary tree and complete binary tree. So make sure, if you not know, you do little Google on complete binary tree and the you can say binary tree, okay? So this question has been asked in Google, Microsoft and Apple, right? This question asked Facebook, right? So it's an important question, as you can see. So there is two approach in which we will do the hands-on, either BFS or you can say DFS, right? So first of all, what we will do, we'll go with DFS approach, this approach, and then we'll do the implementation, okay? So our problem this one is given in you can say the concept of you can say this problem actually defines the concept of you can say the width of a binary tree, right? So in the essence it is about binary tree, right? So in the essence of binary tree traversal, right, we need to traverse the tree in order to measure its width. So as we know, probably, right, we know that the common strategy to traverse a binary tree as a breadth first search, right, depth first search, you can say. Furthermore, the depth first search can be distinguished as a predefined pre-order DFS, in-order DFS, post-order DFS. It's all depending on the relative order of the visited among all the nodes, right? So if one is not familiar with the concept of BFS or DFS, right, then he should do, right? Let's suppose that the indices of the first and the last node of the particular level is given, right? So we can calculate the length like how, let's suppose two nodes we have given, last two nodes we have in the first and the last two nodes in a level, right? So this is the level, let's suppose we have, right? So for this level, leftmost you know, rightmost you know, right? If we'll consider this is C1 and C2 we have given, not C2, let's suppose Cn, okay? So this is the leftmost and this is the rightmost, so I'll take Cn, okay? So if we want to calculate the width, right, so if we want to calculate the width, what will happen? Cn minus Ci and plus 1, correct? So this will become the width, okay? So so let us try to come up with the schema to index the node, so that the problem can be solved easily with the this formula, right? And the indices, if the index of a parent node, that is called Cn, or you can say Ci, this one, let's suppose we can define the index of its left children node as 2, and C1 will take as the index of the right children node as 2 into Ci plus 1, we can say, right? So what we will do, if let's suppose if there is a parent node that is Ci, right, and if the index of the parent node is what, Ci we have, and we can define the leftmost is what, 2 into Ci, right, and the rightmost will become what, 2 into Ci plus 1. So this is your leftmost, and this is your rightmost. Okay, leftmost and rightmost, and this is the indices, the two indices. Okay, I think you got me. Okay, so two indices we have given. This is the indices of the you can say parent node. This is the indices of parent node indices, right? So parent node indices we have, we have given Ci, so we will say this is the thing we have. Okay, let me clean and then I'll write again. So what I'm trying to say, actually, if there is a parent, right, and its index is Ci, okay, so for the leftmost it will become what, we have left child, right, so the left child becomes Ci, 2 into Ci, and right child become 2 Ci plus 1, we can say. Okay, so this is your leftmost and this is your rightmost children. Okay, so now we will let's suppose we are talking about the breadth first search, right? So in the breadth first search, what will happen, we have to understand how the index works for a full binary tree, right? So where each node we label its index rather than its value. Okay, so we have this one, right? So for each level we have to define, right, like this is L1, this is L2, this is L3, right? So in the breadth first search, what is happening, we will go by level. First we'll complete this level, this will complete this level, then we'll complete this level, like this we will do, right? But in the breadth first search, what is happening, we'll take either left children, left, or either we'll take right. Okay, and we'll dig all its children. Okay, it's all children at a time. Then we'll do a backtrack and we'll come back to here, right? After backtracking, we'll traverse its other branch, you can say right children, right? First we will cover this one, and while we backtracking we'll go to this right children, right? So first we'll go to all its index and then we'll try to do, right? So similarly, if we'll talk about this one, right, breadth first search, right? So it's very easy, and what we have to do, actually, after like the width we will measure among the nodes on the same level, right? So what we will do, you can or like let's say you will make a breadth first search, right, BFS traversal first, right, and there are several ways to implement the breadth first search traversal. So among all, there is a common share point, that is using the queue data structure, right, to maintain the order of visits, you can say. So if in detail we will say, we will push the node into the queue level by level, and as a result the priority of the visiting would roll out from top to down and from left to right. So due to the FIFO, right, first in first out, the principle of the queue data structure, the element that enters into the queue would first exit from as well, right? So what we will do, let's understand, we'll do little hands-on, okay, and then we'll do the implementation. Okay, so if we will talk about the breadth first search, if we'll do breadth first implementation, right? So what we have to do, actually, let's go to the browser section, then we will do the implementation. Okay, and we have given root as its parameters. So first of all we'll check what if root is equal to null, we will return null, or not null, 0, the width is 0. And first of all, what we will do, we'll create one queue, and we'll push it a node and column index, right? So how to do that? First of all, we'll take that is called queue. This is our queue, right? And this queue will take what, let's suppose we write it right now. Okay, so first of all we'll take linked list, and this linked list will take pair. So from Java 9, right, we have a pair, as you can see. So this pair will take two things. We can pass our class, that is tree node we have given above, and another will take integer, right? So it will take a pair of tree node and integer, and this is nothing but, you can say, if you write, this is or your node and column index. Okay, so this is your node, tree node, and this is your column index. Okay, ci that I was explaining. Okay, so next we'll take q, and this q will take what? New linked list, and this will take like this. Okay, now coming back to here, what we should do now, we will take a max width, right? So let's suppose this is our integer and this is the max width. Okay, this max width we have to return actually. So initially we'll take a 0, and each time we will update is this one, right? So first of all, what we will do, we have q, then we'll on the q will add, let me hide this one actually. Yeah, now what we will do, we have q, let me zoom a little bit. What we have, q dot add we will do, and there is add last, right? So first of all we'll add, there is method add last. I don't know why it is not showing. So there is a method, let's see, we'll see the compile time, right? Okay, so we'll take a new pair, we will add a new pair each time, and we'll push two things. The first is our root, right? And sorry, root, and another is we'll take is 0 index, right? Index 0, and now we'll move on to the while loop, right? So we know that we have just added onto the queue, so we'll add onto queue, we'll check onto the queue dot size. Okay, I don't know why it is not coming. Queue dot size will take, and we'll check the size, this one, and if this is greater than 0, means we have the element into here. Okay, so let me check here. I have completed this one here, and this, yeah, it should work actually. Okay, now what we have to do actually, we have this pair, right? This pair we have already taken, right? This pair. So this pair I'll write here, and we'll say this is our head of the queue, right? And from the head we'll get our data, right? Let's q dot will do get first is a method from where we'll get our queue data, right? We'll get each time, and then we'll iterate over the current level, right? Each level we will get. So to find the current level, we have a integer, right? And we can say let's suppose current level we have, right? Current level we can give, and this current level, the current level size actually, it will take what? Q dot size, right? Like this. Okay, now what we should do now, once we have our, we will iterating through the current level, so we will have the current this one, right? Now we can take a initial, will take a element, right? Let me write this one. We'll take a pair of tree node, and you can say integer, right? And this will we can say this is our element, and this element is initially what is null, right? Now we will come to the loop, we'll make a loop. We have our current level, so I'll start with I int I equal to 0, and on the level we'll go to what? It's all its current size, right? So I should be less than, you can say, we have created our current level size, and I plus plus, right? So in the all the level we'll move here, and we'll put one by one we'll get our element. So to get the, we'll get element data from where? The queue, right? So from the queue we have to just do remove first. There is a method remove first, we'll get from there, from the queue only. And now we have what? Element. So from the element we'll call our get key function, right? From the pair we can get our element, right? So while getting the pair, first pair, it will call let's suppose this is our node, right? We know that, and this is our tree node, right? As you can see, right? So this element that we have created, another is this is a tree node, this is integer. So this is our key and this is our value pair, okay, from the pair. Now what we will do now, actually we will move on to left and right, right? So we'll check our left and right thing, right? So if we'll check if node contains, node have left, right? Node have left and it is not null, right? It is not null. Then what we should do, we'll check that the queue we have, and we'll do add last, right? Add last, and here we'll pass what we have pair that we used to add, right? Where is that? This one. Like this we are doing actually, this one, this line of code we have to write here, at last. Okay, so in the pair, now this time we are not passing root, but this time passing what? Current node we have, from the left we will pass, right? Left. And at the time of index, right? This index is what? Left. For the left we know that we'll do 2 into what? 2 into element dot its index. Index is what? Get value. Got it? This one. Now this is done. Similarly we'll do else, or else if you can write, or you can make a new if you can make. Let's suppose we'll take let me remove this one back, and we'll copy this one only, we'll paste. At that time left I'll write right, and here I will write right, and 2 plus 1 new, right? Ci plus 2 into Ci plus 1, like this. Okay, this is done. Now what will happen, after calculating the length of the current level and by comparing the first and the last column index, we have to find max, right? So once this is done, this loop is done, we have element, right? So now we have we have max width, max. I've taken max width actually, yeah, this one. So we cannot take like this actually, this is variable, so I'll take like this, okay? That's why it was not coming. Max width equal to we can find from what? Math dot max, and we'll pass two things, our max width, then element dot there is a get value, right? Which one is max, and then another will take we'll do minus actually head value, head dot get value, like this, and we'll do +1. And I think this is done. Before this one we should return our max width. Let me compile, then I'll explain. It's working. Let me submit. Yeah, it's working. So see, let me, what I'll tell, I will do what I can do. Let me, okay, so actually what I am doing here, right? So first of all we'll go to the, we'll check the root node. If root node is null, we'll take a pair of node, you can say, and its current column index, right? And this is actually a parent node actually in index, right? So for the parent node we know that we have two things, either we'll go into leftmost and rightmost. For the leftmost we'll go what? 2 into Ci, and if for the rightmost we'll go 2 into Ci plus 1, right? That's things we are doing. So just we are adding the current we are adding the root, and we are getting the root from there, and for each level we are making, for each level we'll move here, and for the leftmost we'll add 2 into here, 2 into you can say index, right? We'll get from here. And for the rightmost, what we'll do, 2 into Ci plus 1 we'll do here, okay? And we'll get our max width, and we'll return this one, right? So for as you can see that, right, if there is a node, n nodes we have written, right, if there is n total number of nodes in the input, right, so we are traversing all the nodes, right, and we are also storing into the queue, right. So for the time complexity and space complexity, tc and sc tc and sc both are what o of n. Okay, so I think if you like this video, please hit subscribe this channel, and if you want to do deep dive into depth first search approach, right, please let me know in the comment box. I'll create a video and then I'll upload, and I'll also inform you. So thank you for watching this video. If you like this video, please subscribe with your friends and Leetcode. Thank you guys. Thank you for watching this video.